Uh, Now let's start with another topic of permutation and combination, and which is saying like the number of combination of n distinct objects taken r at a time when any object may be repeated any number of times. So the theory is saying like we have n distinct objects a1, a2, a3, a4 and an. So the maximum number of times we can choose a1 is r, a2 is r, a3 is r, a4 is r, an is r. So there is no limitations, like we can choose a1 r at a time, we can choose a2 r at a time, we can choose a3 r at a time, and so on. But we have to select only r objects. So let's see how it works. So we have a1, a2, a3 till an minus 1, and this last one represents an. Now we have to fill our places with a1, a2, a3 and an minus 1. These spaces represents our places. So let's take one example. We have 1, 2, 3, 4 till r, a1, a2, a3, an minus 1. So what does it represents? Like we have chosen a1 r times, we haven't chosen a2, we haven't chosen a3, and we haven't chosen this an minus 1, and we haven't chosen an, but we have choose like a1 r at a times. So we are not allowed to permute these r spaces. We are not allowed to permute these a1, a2, a3 and an minus 1. So we have how many different objects? N minus 1. N minus 1 plus r factorial upon n minus 1 factorial upon into r factorial, which is nothing but n minus 1 plus r cr. Think about it. Let's do a question, and the question is saying in how many ways 3 letters can be posted in 4 letter boxes if all the letters are not posted in the same letter box. So we have letter 1. It can go either into first letter box or second letter box or third letter box and fourth letter box. So we have four options to post this letter 1 into 4 different letter boxes. Same goes with L2, same goes with L3. So we have 4 is the power 3 options. So but there is a condition that we are not required to post all the letters in the same box. So we have to minus 4. So the answer should be 60. Let's just do a different question, and the question says that the number of ways in which 10 candidates A1, A2, A10 can be ranked such that A1 is always above A10. So what the question is saying, like there are 10 candidates in a class and there is an examination, and in that exam A1 have to score higher than A10. So we have 10 candidates, A1, A2 and A10. So don't you think in we have 10 candidates, so uh, the total number of arrangement should be 10 factorial? Don't you think in half of the cases A1 will score higher than A10, and in half of the cases A10 will score higher than A1? So the total number of cases should be 10 factorial by 2. So this is very intuitive, but if you want to solve it theoretically, so what we have to do, like, we have to put A1 and A10, and we have like 8 candidates. So we have to fix A1 and A10 here, and then we have to calculate the rest of the permutation, but we can't permute these A1 and A10. So the answer should be 10 factorial, and we can't permute this A1 and A10, so it should be like 10 factorial divided by 2 factorial. Yep.